Hello, welcome to the Introduction to Engineering Notebooks. We're going to be talking about one of the items you need to deliver along with your robot. And the information that we're going to be talking about is available from the Best National Registry, from the team workflow under Files Shared with Your Team. And the items listed here are available there. Each student needs to make sure their parents create their National Registry account in order to be able to access the files on the registry team workflow. So I am Linda King, and this again is the Intro to Engineering Notebooks. Not only you're going to be building a robot like the lower left, but your team will be needing to build an engineering notebook, and it requires some assembly, just like the robot to the left. And we're going to be going through lots of information to make you successful in doing that. In order for you to compete with your robot at the game day competition, you need to have delivered an engineering notebook. The due date and time for this delivery is defined in the registry under your team workflow under tasks and deliverables. And the way you upload your file is also through the registry workflow under team file panel. You mark the file as primary, and that way we can access it. We will then judge the engineering notebooks. We'll provide scores and comments back to you so you'll know how you can improve in the future. You'll get those scores and comments on game day. So my goal for you today is to help you to be successful in creating your notebook so that you can get as many points as possible. And the other piece is that you don't panic before the submittal deadline. And so we're going to talk about what's required as well as some tips from other teams, as well as from the judges. So what we're going to cover is exactly what is a best engineering notebook, what is an engineering design process, going to show you examples of both the robot design process and the software development process. Going to talk to you about how you're evaluated, what the judges look for. That includes requirements, criteria, and a score sheet. We're going to wrap it up with some tips on how to design a notebook and how to get some help and talk about questions. So first, what exactly is the purpose of building a notebook? So in almost any career that you may pursue, you probably have to document what you've been doing to the people you work for. So in this one, our goal is to document the process that your team has used to design, build, and test your robot. So when you think about that, what does that mean? So one way of looking at it is sort of like a story of what your team did in building the robot. You want to talk about all the steps that you took to create your robot. And you want to start really with day one. So day one is when you learn what the game is. And understanding the game is a critical part. So you start with day one and you document everything you've done. So keeping something like a diary or a log or a folder or just something to capture everything you've done so that you can take that material and you can put them into your notebook. This can include pictures and drawings, as well as notes that you've taken. And we're going to talk more about how you take all those pieces and put it together into a formal notebook. I think you can also think of it like a report on building your robot. So why do we want you to do this? So one of the primary things we teach in Best Robotics is the engineering design process. I'm going to talk about that in more detail. And the documentation associated with that is a critical aspect. So it talks about providing a record of what you've done. And this way you can share between groups. If you have one group that's doing one piece of the robot and another group doing another piece, you can share the information about your piece between those groups. And also if you have someone coming in new or someone that has to be gone for a couple of days, you can show them the documentation that you have to help them get back up to speed or bring them up to speed for the first time. Let's talk about, at a top level, what is this engineering notebook? So it is a PDF file, which you can create from something like Google Doc or Microsoft Word. There may be other tools also. And it has a title page, that first green box. It has a table of contents, the second green box. Neither of those have a page on it. And then it has up to 35 pages of a main document. And those are that darker blue on this page. And then there's, additionally, you can have up to 40 pages of support document, which then refers back to the main document. And we're going to talk more about what all this looks like. But this is at a top level, all the pieces you have. So if a title page is one page, a table of contents could be one or more. Let's say it's one. And let's say you go all the way up to 35, so that's 37 pages. And let's say you have 40 pages of support document, which is also sometimes called an appendix. So that would be 77 pages is how long this could be. It doesn't have to be that long, but you have up to that amount of pages that you can create. And I'm going to talk about the two blue boxes next. Now the actual contents I have listed here at a very high level. The darker blue is the 35 pages. It has 7 pieces of information that you need to talk about. And we're going to talk about engineering design process, the first one, in more detail in a little bit. And then we'll talk about more detail of what's required for the other 7 pieces. And then the support document, which can be up to 40 pages, here it lists 5 different things you could consider putting in. Those are all good things to put in. You may put additional lists, examples of tests, examples of a contract you have for safety. So these support that main document. Safety is a great way to talk about it. We ask you to describe your safety program, and you can talk about a safety program having tests and having a contract, and you can put the details in your support document. And in that main document, you would just refer to what is in the appendix there. And to help you understand how you put these documents together, I have listed here 2 examples, and each one has a link to the file if you want to look at it in more detail. And I'm trying to show you with the green representing the title page and the table of contents, the blue being the main text, the dark blue, and then the lighter blue being that support document, the appendix. These 2 schools in 2011 and 2012 created excellent engineering notebooks. They are all high schools. They're very accomplished engineering notebooks, and they're there to inspire you and give you examples. So each one of these components are listed here, and they each do them differently. There is no right answer to a table of contents. So you need all the material, but you can group it and present it in any way that makes sense to you. I'm including these here so you have an idea of how 2 different schools did that. But they all have that green title page and table of contents, and they all have an appendix at the end, and they all have the main text, and they cover the information. The reason the software development is in red is because there is not an example in these documents. It was new in 2015, and you don't see it. So you can click at the bottom and get 5 more examples if that would be helpful for you at the link provided. I mentioned one of the critical pieces that we teach is the engineering design process. So I'm going to talk to you and provide some examples again. I want to talk to you about why it's important. It is basically like, I guess you could think of it like a recipe for how to solve a particular problem, and they view it within objectives and constraints. So let's talk about that a little bit more. So I said it's like a recipe. So your recipe has a list of steps that you need to do. And it also has ingredients, and you can think of those as some of the constraints. In order to build this, whatever it is that you're doing a recipe for, let's say it's a cake, you need to have all the ingredients. So it has certain constraints of what you need to use. You need all those ingredients. It also says what temperature it has to be, how long you have to cook it. And the objectives is usually something like a picture of what you want to do. If you're going to build a birthday cake, you're looking for a recipe that has something that your friend who's having a birthday would like their cake for. So your friend says they would like to have a carrot cake. So your objectives is to build a carrot cake, and the process that you've looked at to do that is the recipe, and the constraints are things like the temperature of the oven, how long, and the ingredients. You can think of that, we're using the engineering design process as a recipe to build a robot. And we want you to describe that and in your notebook, and we're going to give you an idea of the steps that you should use to build a good robot, and that's what I'll talk about next. Now it can be used, these steps, going through them for a whole robot, components, even for your engineering notebook, and for an optional Best Award marketing presentation if your group is doing that. So it helps you, this process, instead of just getting out and cutting wood and plywood and PVC and writing some code and putting something together without any objectivity of what are you trying to achieve and what are your constraints, it makes it very difficult. You could end up with something that does not achieve what you want it to, and maybe you'll build it 2 weeks after the end date, or you'll build it with some pieces of robot material that wasn't given to you and wasn't in the rules, therefore your robot will be considered non-compliant and you cannot compete. So it helps, having the structure of this recipe, in my mind, will help you do that. And it also helps you identify problems early. So if you go slowly and you look at what's in the rules, similar to what's in the ingredients on your recipe, and if you find out on your recipe you need 2 hours, so you need to make sure you start your cake building early enough. Similarly, you'd be able to identify your problems early relative to completing on time. Also, one of the rules for the robot, it can't be larger than something that would fit in a 2 foot by 2 foot by 2 foot cube. And if it was that big and you were bringing it 2 weeks before game day and you put it in the box that we have to measure compliance, you would have wasted a lot of time and you would have very little time to go forward. So it helps you identify those problems early, and we'll talk more about this. This slide and the next one gives you 2 examples of a design process. I am providing these examples, and you may actually take these and use it in your notebook if this fits what your process was. We encourage you to consider a process like this. There's a lot of different ways to define an engineering design process. This is one that is a good one and that you could consider putting in your notebook. So on the left, I have a graphic that shows the flow of the 7 steps that are to the right. I also have 2 yellow arrows. Your engineering notebook needs to talk about from the light blue down to the medium blue in steps 1 through 7. Whereas for critical design review, which is called a CDR, which is something else your team needs to do, it would stop earlier and only consider the light blue. So let's talk briefly about these 7 steps. The first one is what you're doing on kickoff. You're understanding the problem. The problem is, how do I score points with my robot and hopefully score enough points to be able to score more than everybody else. So to understand what it is to do this game, you need to read the rules. And that's about a 60-page document. It's probably less than that. It's probably more like 40. But there's a lot of details in there. And you need to understand, based on the rules, what is it that your robot is required to do. So in general, you need to pick up and move things. So you need to understand that, and you need to understand how many points do you get for picking up and moving whatever it is that you're required to do. Understanding the problem, you can also look at other designs that might, of a robot that might do this kind of work. And you can inventory the resources you have available. So an example of that is your robot kit. You can only use the material we've given you, and with some exceptions that are defined in the rules. So you need to understand what this problem is, all components of it. So this could be a couple of days, a couple of hours. It's time you need to spend thinking about that, and you need to do that first. So in baking this cake is you need to understand what your friend wants. You need to understand when the party is that you're bringing this cake. You need to understand what ingredients you have. So it's doing all that before you start mixing flour and butter and sugar. You wouldn't just jump into that. So similarly for your robot, you wouldn't jump into that. So different than your recipe, you have some constraints, but there's a lot of it that is totally up to your team. All robots are going to be different when we get to the competition. And you need to think about what kind of strategy you're going to go for in scoring points and what kind of designs you're going to look at. And brainstorming is a group activity. It can be very effective or it can be chaos. And thinking about how you're going to do that is an important part of doing your design. And you need to consider, as you look at various strategies and designs, go back and consider the rules that you have. Which way are the most points that you can score? How complex a robot can you make, and can you achieve some of those things with the design you might be able to do? So you want to brainstorm both your strategy for scoring and your robot design, and then you want to select a first cut at what you want to consider. This could be one design or multiple designs if you have time. And as part of looking at that brainstorming, again, you want to do it in an organized fashion, not someone's favorite or loudest, but you want to use it in a structure that you consider the rules and the requirements. So once you come up with an initial concept, then you want to analyze it and prototype it. So a simple model or prototype, it could be a drawing, it could be something with cardboard, it could be a computer-aided design, but you want to try different things and test it out against what the rules say and what the requirements are. There's one suggestion that you fail early and often. You're not expected to get this right in the first one you consider. It would be very unusual. So you want to look at what your options are. And as you're considering these, you consider what you brainstorm and you go again back to the rules. This is a very iterative process. That's what those arrows mean. You go forward, you learn more, you go back and look at it, and then you go forward again. So once you have prototyped something and have a design, so maybe this is a week or two in, you haven't even touched your kit yet in any real sense, then you actually, quote, manufacture it, or you fabricate it, or you use saws and shears and screws and nuts, and you go through that. You're also, which we're going to talk about next, going to be considering software associated with this. And although we're showing them as two different processes, they need to work together. So what the software does is it controls the robot. If you have a motor with a wheel attached to a base, it's your way to use a joystick to tell that motor what you want it to do based on what the joystick is doing. So that's what your software is doing. We're going to talk about that next, but that's part of making your design work. Then you want to integrate and test, so if someone is working on the wheels, someone else is working on an arm, you want to bring those pieces together and you want to test, and you want to make sure the software works in it. And then you want to assemble it all together, put the arm perhaps on a platform and the wheels, attach it. Then you want to test it. And you want to see what works and what doesn't work, and you want to go back and repeat steps as you can. And then you want to deliver the product. You want to bring it to game day and have it pass compliance, have your notebook turned in, and be able to use it on a game field. So I talked about software just in the previous chart, that you need to bring it all together. So as well as building the actual robot, you may have someone else that is looking at the software. You've got a couple of different options, 3 different options on software that you can use. And once you've decided on that, you want to understand what it is that your software needs to accomplish, without really saying how it's going to do it. So the things that your software accomplishes are probably things like, we're going to move the wheels, we're going to use the joystick to move the wheels. We're going to use the joystick to move an arm or some kind of grabber kind of thing. And as your folks, the other folks, are looking at their robot design, you need to be working closely with them. And if they're defining what they're trying to do, you would also be defining what you're doing. And you need to work as you go along to understand what it is that their design needs and what it is that you need to accomplish. And then the second step is design how the software is going to do that. And usually that's saying, what on my joystick am I going to use to control the wheels? What are all the pieces? There's certain components on a joystick. Understanding the joystick is a critical part of doing your software. And so being able to say, I know the robot's going to have 2 wheels with motors. Where am I going to control that from my joystick? So that's what you're going to need to do. And again, like the robot engineering design process, the CDR ends, the critical design review ends at design. So you're documenting what you've done on the design phase. You then put in a presentation for the critical design review. You continue with the software code that you wrote, and you talk about what software you've written in your notebook under step 3. You talk about how you've tested and verified it. You can use a simulator, you can use the robot, you can check by looking at the code, but you want to talk about everything that you've planned to do with the robot, with the software, and see if it all works. So that's looking at items 1, 2, and 3. And then the other part that is unique, these items before are pretty similar to what you did with the engineering design process in your robot, but somewhat unique to software is, how do you version your software? Just like a document, sometimes you may have a date on your software, but how do you know what version your software is? Let's say you tried something and you needed to add a motor, and you're going to create a new file that adds the motor, and you want it separate from the file without the motor to make sure you don't break it, the part that was created before. So you create a new version, let's say it's version 2, and you're adding the motors. And I would suggest you have a table that on each version you talk about what was changed from the previous version. So that's your process of how you are managing the actual versions. Talk about also how you release it to folks. So if you're giving the software to someone who's testing, how do you let them know what it is and where it is? So you want to talk about giving the software to the people that are testing and running the robot. So that's the deployment. That's the release to others. So this is the software development process, and these two processes need to go into your notebook, and you need to talk about how you did it. This example talks about the kinds of things you need to talk about, but the way you've done it is different for each one of these, and it needs to go into the notebook. And again, you can use this example if you have a better one that covers all these, that you perhaps are similar. The words are a little different, that's fine. You can also put this process in your notebook. So now we're going to talk more about how the notebook is scored, which really gives you insight into what you need, the details of what you need to put in your notebook. So this specification section and the next 3 pages after this are in the competition rules. And I've copied these here, and the green items are some tips. So if I run through these real quickly, these 5 items, we've already talked about many of them. You need to deliver the notebook in a PDF file, and you need to put 1 file on your National Registry workflow page for the deliverables. Second, you need to have that title page. It has very specific information that it needs to be included, and if you don't put it on, you will lose points. And this is an area real easy to do, but real easy to forget all the details. So you need to make sure all those details are on that page. And you can do this day 1. You can leave here watching this presentation and start creating a file that has a title page. That third one, it needs to have 35 pages or less, and the title page and the table of contents are not part of that. And so that's your main text. It talks about single-sided, which really doesn't make sense in an electronic form, but it needs to be 35 pages or less. The document then needs to have very specific standards. It needs to be 8.5 by 11 paper if you print it. It needs to be double space. Do not forget this. It's not single space. Double space is kind of unusual. Remember, it needs to be double space, otherwise you lose points. It needs to have a 1-inch margin. Don't forget that either. And we recommend Times New Roman font, but you can use a similar font, and we don't want it any smaller than 12 points. You can do single spacing in tables and outlines. And then number 5, which we've also talked about, it may include a supplemental appendix, which we call support documentation, no more than 40 pages again. And here's some examples of items you should include in there. And it should support what is in the primary document, and it shouldn't reflect anything that's outside of what the primary document has. And there's some examples in there. If you put those other items in your notebook, you will lose points. Now we're going to talk about another part of your evaluation of your engineering notebook. And this is also in the competition rules. This is part of what is used in the scoring of your notebook. And since your goal here is to get lots of points on your engineering notebook, you need to consider all of these rules, evaluation criteria, in order to get higher points for your notebook. So the first item on here is, of this page 1 of 3, is the engineering design process. And I gave you an example on page 10 of an engineering design process. If that is the process that you use and those words make sense, use that graphic and those words as what your process is. And if you did something differently, then just change that graphic and change the words to reflect what you did going through. But we recommend you consider that process or something very similar as a guide to help you work through here. So one of the first steps on that process, to use as an example, is understand the problem. So your problem with your robot is to score a lot of points on the game field. And understanding that is reading the rules. So what you would include on your engineering design process section is said, we understood the problem, and these are the rules that we use to help us decide what we want to do. We decided that the most important ones are these pieces, and maybe you put a summary of it in your appendix. So you would say, in order to get a certain number of points, we need to do a certain thing. And then you would describe that as what the problem was. In order for you to score a lot of points, you need to solve that problem. You need to accomplish that task. So it might mean moving something on the game field to another place on the game field and for a certain amount of points. And you would talk about that. You would talk about your robot needing to be fit in a 2x2 by 2 foot box. That is part of understanding your problem. So coming up with, as I suggest, a table of all those important things that you need to remember to do, instead of referring back to the rules, you would have a list that you could easily work with. And reflecting that in your support document is certainly a way to do that, or put it in your main document. You have flexibility of where you're going to do that. So that would be examples of evidence that you understood the problem, which was your first step in your engineering process. So the second item on this list is a research paper. There's quite a few entries under this section that describe what you need to include, and you need to satisfy and include each of those items associated with that relative to the demo day's game. So once you get the rules and understand that, you need to go through and generate within those 35 pages a minimum of 2 pages and a maximum of 5 pages. And you need to talk about each one. And what I would suggest, there's a web posting called Bestology. The link is on here, or if you search for Best Robotics Bestology 2021, you'll be able to look at 9 postings that talk about the theme of this year's game. It's a great place to start. Assigning this section of the notebook to 1 or 2 people would be probably a great idea. Make sure somebody spends the time to go through doing that. So item 3 on here is brainstorming. It's discussed in your engineering design process, what you did. And what you want to do is describe even more detail exactly how you did brainstorming. And document what you did, each of the options your team considered, and then which one you selected and how did you decide which you selected. So that is the tip on that one. On the second page of evaluation criteria, we're talking about 3 additional items 4, 5, and 6 here of the 7 that we identified earlier. Items 4 and 5 are probably the most difficult ones that teams look at when doing an engineering notebook. And I suggest you take a look at some of the example engineering notebooks and see how they've attacked these sections to give you some ideas. Let's start with analytical evaluation of design alternatives. So what you're looking here is part of your brainstorming or prototyping as you're considering options, which you should call as alternatives so that judges can find them. You will be evaluated to see how well you analyzed it and what math skills you used to evaluate. And as the tip shows, there is a coach's survival guide that's under the resources section of the BEST homepage under participants. So go participants, resources, and it's near the bottom. Coach's survival guide. And on page 44, it talks about making a decision with a decision matrix. And a decision matrix is an excellent analytical tool that helps you clearly express how you evaluated your alternatives. So, and then also mathematical skills, if you're looking to see how long an arm needs to be in order to put raise something up to a certain height, you will be using math for that. And there's other opportunities also to use math. So this one, again, consider the example engineering notebooks. And then offensive and defensive evaluation. This particular section, you want to be talking in your notebook about your goals, and the goals should be how you're going to be doing your scoring. So you should have some scoring goals. You're going to go after certain game field pieces with certain points, and you want to talk about how you're going to go about scoring those points and the strategies you're going to use, so what your robot's going to do to score those points, that's your strategy, and how that works within a 3-minute match that your robot's going to be doing at game day. So that is the offensive side. On the defensive side, sometimes a team can prevent a robot from getting points, a different robot. But in this particular game, Demo Days, each robot will be on their own section of field and there's no interaction there. So that doesn't apply this year. The final piece on this page is software design, and going back to, I think it was page 11, we listed these 5 items. We had a graphic and a description of them. And this, again, highlights what you need to be putting into this section in the notebook. And again, you need evidence that shows how you did each of those, and we talked about that a little bit earlier. So you should have a list of what's that the robot needs to do. You should have a list of how's the robot's going to do that. You should talk about the techniques you use for your programming. One example is flowing out the tasks it needs to do in like a flow chart. Another is a table of all the things it needs to do, perhaps to your joystick. Talk about how you tested, and talk about that deployment that we talked about extensively. So again, each of those 5 processes need to be in the notebook. A critical part of BEST robotics is to build your robot safely. There are hazards in working with tools, and you need to make sure you have the training on working with those tools and other pieces of equipment, even if it's scissors, that you know how to use them and that you follow how you're supposed to use them. And you want to make sure you don't get injured, the robot doesn't get injured, the table, the floor doesn't get injured, nothing is damaged. So under the tip, things you consider, talk about what training, evidence of training, who gave the training, who attended the training, what was the training, and how did you make sure people were trained. So talk about and how you confirmed that people followed those practices. And there's some examples in there under the green that you should consider. So that's covered all the pieces of the main document. Then the lighter blue square, the support document or the appendix. Again, this is 40 pages or 20 double-sided. You have to reference items that are in here. If you have a test result, you want to say in your main document what section of the support document that your test results are on. You can do this by sections. You can say section 1, 2, 3, so far, so, or something similar, or the page number where the test results exist. So you want to be able to see where in that support document those test results are when you're talking about it in your main document. That's as an example. So then number 9 is not specific to either of those blue squares that we talked about initially, but it applies overall. What's the quality and completeness of it? Did you follow the organization that you showed in your table of contents? Is it easy to follow? Is it nicely put together? You adhere to all the specifications that we talked about before we started talking about evaluation. Is it 8.5 by 11 page? Is it 1 inch? Is it the right fonts? And how good was the content? Was it easy to understand and follow? So this is an easy way to get points. It's also an easy way to lose points. So make sure you go back to the specifications, and all of those are covered before you submit your notebook. So associated with those evaluation criteria and the specification, there's a score sheet that the judges use. And it has 3 main sections, and I'm going to show you those. You can see that the engineering design process of the 30 points is the biggest section. And the research paper has its own scoring, and quality and completeness. So even if your notebook content isn't really great, if it's the quality and completeness is there, you can still get 9 points. So it shows 30 points. When we look at the notebook, the total on each of the sections is 10 times higher. So the total you'll see on summing up the points there is 300 points, and then at the end we divide by 10 to get 30. So again, some tips: make it easy for judges to find evidence. Use the same words that are in the evaluation and specification. Give specific examples for all those items, and follow the structure of the score sheet. Make sure it's easy to see in your table of contents how the information in your document fits the score sheet. So next we're going to look at the 3 pages of the score sheet. Starting from page 1, as you saw in the summary, the research paper is 4 points or 40 points. And you see the possible points there add up to 40. And these are what our judges are going to look at, and they'll give you a score for each of those. So if you don't use information such as history, inventor, or milestones, if they can't find that in your document, you will lose 5 points. If you don't make it 2 to 5 pages, you'll lose some portion of the 10 points that is possible for that area on this score sheet. So here's the 4 points for research paper. Design process then goes through 17, and it continues on the next page. So design process is continuing, and we talked about the section of offensive and defensive, software development, safety, and support documentation is under this one also. So this is all scored as part of that 17 or 170 points. And if you miss any of the pieces here, you will knock down from the 25 points. So the rubric is, the green is talking about what you need to do to make sure that you achieve those points at a top level. So the final section of the score sheet talks about that quality and completeness. It's talking about in the organizations you have page numbers and table of contents, and we'll talk a little bit more about how you make sure you can do that with your tool. Talks about having a cover sheet and the name of your teacher and their contact and the margins, and talks about under quality, well written, having labels, not having extraneous information. So all this is how you can get those 9 points, or the sum of the individual pieces being 90. And so that gives you a total of 300 divided by 10, and that gives you the 30 points that are associated with your engineering notebook. So that score sheet is what our judges use. And so we have a team of professionals that have worked in software and engineering, and they're going to use those score sheets, and they're going to provide you comments on how, and give you a score and provide you comments on how you can improve. So in order to help the judges, they're trying to give you as many points as they can. So if you can make it easy for them to find a topic that's on the score sheet, if it asks for a table of contents, maybe make sure you put something in there that's called a table of contents. If it asks for safety and talk about training, make sure you have the words safety and training in there. If it talks about software deployment, make sure you talk in your notebook about software deployment. That way the judges can easily find in your notebook those items and can give you the points. And again, you will receive those comments in the National Registry after game day, as well as the scores. We talked at the beginning how in order to compete with a robot at game day, you need to submit an engineering notebook at practice day. So without that notebook, which is the key to the competition, you don't open the door to be able to run your robot. So, but there's other ways the notebook score is used. It's the score itself, that 30 up to 30 points, is part of the BEST Award, and there's separate training about how that plays into the BEST Award. It's used for the Founders Award, which has a set of score sheets that talks about how that's used. It's also used for an Engineering Notebook Award for a non-BEST Award team. There's actually a trophy for that. So even if you're not doing pieces of the BEST Award, you can still be eligible for a trophy associated with a notebook. We also use it for the Software Development Award, and we use the section in the notebook, the score that you achieve there, to award a trophy associated with that. Let's take a couple minutes to talk about designing an engineering notebook. I'm going to run through these quickly. We're going to look at steps that you can take, table of contents, and a 45-minute quick start. So let's get on it. These next 2 pages talk about using the engineering design process that we talked back in the beginning about designing your engineering notebook. So similar to a robot having game rules, we talked about the rules in the rules document, the specification evaluation for producing an engineering notebook, for scoring an engineering notebook. So under there, it talks about reading those. It then talks about considering tools, outlines, thinking about the skills you need in order to have create a notebook. Maybe you need someone that can take pictures, someone that can use Google Docs, someone that's good at organizing. Think about all those things. Then it talks about having a draft table of contents, getting team members, having a rough draft further, and looking at your team members that are going to do this, making sure you have all the tools fit together, coming up with a first draft, using tools, responsibilities, schedule, finalizing all that. So getting your plan together. So this chart 2 then continues the process, talking about further refining your document, coming up with a detailed outline. And this is all through here is something you can do easily in the first week. You've got quite a few weeks to build an engineering notebook, but not quite as many as your robot, so you need to plan your time. So getting these initial steps to define exactly what you're doing is really critical to be successful. So coming up with a plan and schedule, as well as your notebook and as well as your outline. And then the main part in the red there is gathering all the information that you're keeping track of, everything associated with the decisions you're making for your robot, the process you're following, and continuing to build that draft document within the structure of the outline you came up with to make sure you're hitting all the points on the score sheet. Then when you've got a draft version, it should be a goal to try to get that, at least an initial draft, days before the due date, and looking at having someone either within your team or perhaps outside of your team take the score sheet and actually give a score for your draft notebook, remembering to put all those items on the title page, and look at the notebook against those specification and criteria, and then go back and revise it. And similar to testing your robot, doing updates, making it better, and using everything on that was in step 8, you do updates, then following the information in the registry for your due date and the time associated with that, you then upload through team files, as we talked about earlier. You need to make sure you've got somebody identified for all these documentation tasks early in those 8 weeks for the total process for your robot, but again, you have fewer weeks to do your engineering notebook. And talk about how you're documenting and keeping track of everything also in your notebook. So similar to the robot, these 2 pages talk about using a disciplined process to go through and produce your engineering notebook. So as you're thinking about a table of contents, here were those 2 from the beginning. So the title page, table of contents in green goes up there, the main document, all the pieces, various ways to put those together, and then the appendix or support document. And then there's additional examples that you can consider. So I suggest you quickly, after reviewing this training, come up with 45 minutes to do a quick start to come up with a table of contents. Each one of the 3 items here is 15 minutes, so going back and looking at those specification and evaluation we looked at, come up with a rough draft, include on each one of those maybe the number of pages you're going to have, and talk about who on the team is responsible for those sections. And then go back and look at your rough draft, kind of test it against the specification and see if everything's in there. And I highly recommend you don't let the first week go by without having a first draft of your table of contents. This chart talks about some tips on how to keep up on producing your engineering notebook. It was provided by a successful team on some ideas of what you can do to make sure you don't have to pull an all-nighter the night before it's due. So this team scheduled a weekly notebook review. At each week, they looked at what are they going to focus on adding to the notebook, who specifically is going to write that, and then who's going to go through and edit it. Taking this piecemeal approach, it's not so overwhelming, and you can keep up with the material. And then at the end, a week before it's due, schedule an internal review and actually score like we talked about. If you can keep up with the notebook and the changes and the items that you need to put in there, you won't be doing that all-nighter the night before. One more tip, we talked about document tools, Google Docs, Microsoft Word. Make sure you know how to work with a table of contents and page number. If you don't know how to do that, click Help on the tool and search for those. If you try to do it manually, it is very cumbersome and prone to error. Make sure you know how to do these. As a reminder of some of the resources that we talked about previously, your engineering notebook requirements are in the competition rules under section 5.1. These are available in the Best National Registry at 9 a.m. on Kickoff Day, and the links listed there. Talked about some engineering notebook examples. There's a link here that on the Best Robotics National page. These are from 2011. Some of the requirements for the notebook at that time were different than what they are today. There wasn't a separate software section, for example. So they'll look a little bit different, but might be a good resource of how teams handled satisfying the various specifications for the notebook. Similar, the 2012 STEM Academy Rocky Mountain Best engineering notebook example is again a little dated relative to the specifications, but it has valuable information. It's an excellent notebook and will perhaps give you some ideas. So as far as contact information, go to your, look at your hub's handbook. Each of us, our hubs will have a handbook and they list contact for people, and look for the engineering notebook one for your hub. So that is all the material I had to present. And if you have questions, please feel to reach out to me via email. And if it's specific to a certain hub, may forward it on your questions to the point of contact in your organization supporting you. A final reminder that this material is going to be available through your Best National Registry and your team workflow. They'll be under files shared with your team. And your need to have a Best National Registry account in order to access the files on your team workflow, and your parents can help you with that. And there's information under the help section in the Best National Registry on how a parent accomplishes getting you your avatar and password. Thanks again.